models of anomalous diffusion. At the last part, I will talk about my further research. First, this is my institute in the Hongguang University, China. Our institute was founded in the 2006. The current director is my tutor, Professor Chen, also focuses on the research about fractional calculus. If you want to get more information about our institute, please browse this website. The current research interests include the constitutive relationship of clay and soft soils based on their soft matter mechanics. The second one is fractional derivative modeling of mechanical physical behavior of soft matters. The last part is mechanics and autotic behavior of food and human tissues. So next I will talk about fractional models. First, about the anomalous diffusions. Anomalous diffusions was extensively observed in many fields such as protron diffusions and turbulence, oil seepage, and other fields. The characteristics include the scale effect, heavy tail, and history dependent and long-range correlations. So from this character, we can say it is similar with the fractional calculus, the history dependent and the long-range correlation. So now the research of anomalous diffusions, the tools is the fractional calculus. But in traditional ways, the scholars like to use the nonlinear models, but the drawbacks of this model is obvious. It has unclear interpretations in physics. Always it needs obscure parameters. In the computations, it will waste a lot of time and money. So here we will list some open issues in the anomalous diffusion modelings. The first problem is how to deal with the diffusion process, which changes with time evolutions, spatial variations, or system parameters. Because this diffusion process, it changes with time and space, so it's difficult to model by the consistent order differential equation. The second problem is the description of multi-scale diffusion or multi-field coupling transport system. The third problem is the diffusion process in homogeneous or anisotropic media. The last problem happened to the link between the differential equation, statistical method, and the CTRW models. So this link has many scholars try to build, but until now the link is incomplete. So here is a big picture of anomalous diffusion modelings. There are three kinds of approach: the fractional differential equations, or statistical method, or CTRW models. Those three models all can describe the anomalous diffusions, but they have the relations with each other. So it's a big picture to the research of the anomalous diffusion. So the first model I will talk about variable order models. Why we select these models? Because, as I have said, that some diffusion behaviors change with time, space, or system parameters. Also, in some diffusion process, they exhibit the accelerating or decelerating diffusion behavior. So, in order to depict this diffusion process, we introduce these variable order models. In my studies, I have divided this model to 4 types, and from the reason why we use this and variable orders, we can see from those equations the difference with the different type models like this. The time derivative orders have different forms. Here is a picture. This is the time-dependent models. We can see from this picture, the diffusion behavior is accelerating diffusion process from alpha equal to 0.6 to alpha equal to 0.8. The second picture is about the concentration-dependent variable order models. This model, we can say, it depicts the accelerating diffusion process from 0.6 to 0.5.